Hey, this is Mr. Aiden. Today we're going to be going through the 2021 AP Chemistry exam, free response number 3. If you haven't taken a look at my website, mraiden.com, make sure you go by there and give it a look, and it'll be the best $29.99 investment that you can possibly make into your AP Chemistry future or your AP Chemistry teaching. So let's get to this question. My students really love this question on the exam because we had gone through it many, many times, and it was exactly what we really spent a lot of time on and teaching, as well as what we see in mraiden.com. I think a lot of students will have tripped up on this question throughout the nation. But you can see here we're trying to find the concentration of copper sulfate. Copper sulfate is a blue solution, and so we're going to use two different procedures. We're going to do precipitation. We're going to do spectrophotometry. And so first we're going to do precipitation. And if you look at our Big 25 reactions, again on mraiden.com, Big 25 reactions, be part of mraiden.com, and you will succeed. And the precipitation reaction is one of our Big 25, and we're going to do the balanced ionic reaction, which means barium nitrate and copper sulfate. What's going to precipitate? The barium ions, Ba+2, that's going to be aqueous, plus the sulfate ions, SO4 minus 2, that's aqueous, and that's going to give you barium sulfate solid. That is a white precipitate, an ionic solid, and so that ionic solid is our precipitate, and that is what is going to form. And then you can see we want to know the moles of the precipitate. Moles of the precipitate. My students know to go to that end result. That end result is the filter paper and the precipitate. So that's 1.136 grams, and that is the barium sulfate and the filter paper, which means we need to subtract the mass of the dry filter paper, 0.764 grams. That's the filter paper, and that's going to leave me with 0.372 grams of just dried barium sulfate. Remember, if they give you a bunch of different values, you're always taking the one at the bottom because that's the one that is dried the most. And so, but that's just grams. Then we have to go 0.372 grams of barium sulfate. And something that I try to drill into my students is put the units and what is it assigned to. You're going to divide by the molar mass, count up the molar mass on your periodic table, and we get the molar mass is 233.39. That's grams per mole. And that ends up giving you 0.001594 moles of barium sulfate. Keep in mind, we want to put what it's assigned to, or the units, and what is it assigned to. Keep it straight, and it makes it a whole heck of a lot easier. So that's letter B. We took our grams of barium sulfate and the filter paper. We subtracted the filter paper, just get grams of barium sulfate. Grams of barium sulfate divided by molar mass gives us moles of barium sulfate. And so next that we want to know the molarity. Okay, so I'm going to do my work for C up here, if that's okay. And I first have to look at my molar ratio. Take a look at my reaction. I have 1 barium for every 1 sulfate for every one barium sulfate. And so I know there's 1 mole of barium sulfate for every 1 mole of sulfate for every 1 mole of copper sulfate, because we want to find out the molarity of copper sulfate. And I already feel weird doing this in red because copper sulfate's blue. Where's 1 mole of barium sulfate for every 1 mole of sulfate for every 1 mole of copper sulfate. It's a 1-to-1-to-1 ratio, which means that we know we have 0.001594 moles of copper sulfate. How do we know that? The moles of barium sulfate is the same as moles of the copper sulfate. And doing this little reasoning right here is sufficient for AP reviewers. To find concentration, I have to do moles and divide by the number of liters. And if you can see, there is 50 mils of copper sulfate, 50 mils. So I have to do 0.050 liters, make sure it's in liters, and that ends up giving me 0.03188 molar of copper sulfate. And that is my answer for letter C. Now we come through and we want to do spectrophotometry now. We were doing precipitation, our what we call gravimetric analysis, and now we're going to do our spectrophotometry, which is dealing with color. Okay, so we're going to take a look at the concentration using color. And it says calculate the volume of 0.1000 molar of copper sulfate needed to make 50.00 mils of 0.0500 molar copper sulfate. Now, we can use M1V1 equals M2V2 because it is a 1-to-1 ratio. Keep in mind, if it's not a 1-to-1 ratio, you can't use this M1V1 equals M2V2, but here the moles are equal to the moles, 1-to-1 molar ratio, so we can use it. We know we have 0.1000 molar. Volume is what we're trying to find. We have 0.0500 molar. We have 50.00 milliliters, and we do our just a little bit of math, our algebra, and we get 25.00 milliliters. We need that volume of the more concentrated to dilute it. And then a laboratory question to describe the procedure. My students have done this multiple times. They know their procedure. I'm going to dispense, first thing is, I'm going to dispense my 25.00 milliliters of my 0.1000 molar of copper sulfate. How am I going to dispense it? I want to dispense it using something like a burette would be really nice. Okay, or you could use a volumetric pipette. Volumetric pipette is really nice because we can get exactly the 25.00 milliliters. Volumetric pipette is beautiful, and we want to dispense that into my 50.00 milliliter volumetric flask. The volumetric flask has one job in life. It's to measure to 50 milliliters. Okay, and then I'm going to fill to the volume with water. Distilled water, DI water, and I'm going to mix well. And that is how we make any kind of dilution using those laboratory equipment. So let's continue on throughout this spectrophotometry problem. We want to know the absorbance of the solution is 0.219er, and that's about 0.22, which is about right there. So if you kind of work your way over and work your way down, I kind of took a good guess, and I get 0.0340 molar. Okay, I'm sure they give you a little bit of a wiggle room on that. Probably somewhere between 0.032 and 0.036, probably something like that. Okay, some sort of wiggle room on that. And the last part of the problem is a second student performs the same experiment. There's a few drops in the cuvette before they add it in. And we want to know, is this going to result in copper sulfate concentration for the unknown that's greater or less, blah, blah, blah. And so we want to just go kind of logically step by step. So a few drops of water, what is a few drops of water going to do? A few drops of water will dilute the copper sulfate. So if it dilutes the copper sulfate, what's that going to do to the absorbance? Okay, and this will cause the absorbance to be less than expected on it because it's diluted. If the absorbance is less than expected, this would result in the concentration of the unknown being less than we obtained in part F. And so that is kind of a logical approach. When I get these kind of laboratory error problems, I just go logically. What does the few drops of water do? What will that do to the absorbance? What will that do to the concentration? I take it step by step, and we end up getting less than part F. And that's question number 3. Hope that helped. and I'll be finishing out this exam probably later today. Thanks, guys. See you later. Bye.